Third-degree polynomial, how many terms should there be? 4. We have all 4. Yes. All right, well, the coefficients. -3, 7, 4, 8. First thing to do is drop the first term. Good. -9, -2, -6, -10, 30, 38.
Wait, 3 times -10.
I was making sure you were paying attention. Good job.
Do you want us to write it as a pair or just write 20 negatives? You used to write negatives, but it's fine.
Wait, so it says what y is?
Yeah. That's what y will equal when you're done. Yes, sir. You don't have to. You can just circle it. It's okay. All right. Ladies and gentlemen, come on. Once again, this is now a 5th degree polynomial. So how many terms should you have?
6.
You should have to have 6 terms in here. So we have to go through and put a bunch of placeholders in. So as you're doing this, you've got a 3, a 0, a 0, -2, a 1, and a 0. You have to put the placeholder in for the constant, otherwise this won't work. That is a huge thing that most people forget, all right? Placeholders go everywhere. Placeholders have to go everywhere, all right? So now you've got your 2. Hopefully I don't screw this one up. 6, 6, 12, 12, 24, 22, 44, 45, 90, 90? Yay! It's a whole lot easier than direct substitution. And it's fast.
It's also fun.
I'm glad you're enjoying yourself synthetically dividing. Okay? So, when you're synthetically dividing, what's going to happen here, probably by the end of today, there's a couple of things that we need to show you. First thing is, we're going to talk about what's called long division. Now, one of the things that you guys should remember is that if I take a value, let's say it's 13, I want to divide into
I like that number.
It is a beautiful number, and there's a lot going on, but the idea here is to remind you of what, in fact, you're doing. So, as you long divided numerically in the past, we kind of looked at this a little bit yesterday, where you were asking yourself, we were looking for remainders, remember that?
Yeah.
Same basic principle here, where I'm going to start the problem with, well, I can't go 13 into 2, so I have to go 13 into 27. How many times does 13 go into 27? 2. Right, twice. So you put the 2 up top. What did you do with the 2 then to the 13 to right below? You multiplied, good. So 2 times 13 is 26. Then what did you do?
You subtract 27.
You subtract and you get 1, and then you brought down the next value, which was the 4. Yeah, kinda. Yeah. So now 13 goes into 14 how many times? Once, okay. Multiply, subtract, bring down the next one. 1, okay. 13.
1 remaining.
Oh, well, that was convenient. 2.
1 remaining.
Does 13 go into 8? What do you put? 0. Very good.
Some people are
And then the last one is the 7 bringing down. So now, now you go 13 times what gets you to 87? Well, we know 13 times 3 would be 39, right? If you double 39, what do you get? 78, right? If I add 13 to 78, would that be more or less than 87? More. So that's where you just kind of bounce around with some of the numbers in your head. So I'm going to say 7. So, well, not 7, I'm sorry. 7 would be too much, so we'll go 6. And we said that was what, 78?
Yeah.
Okay. Subtract that through, you have a leftover of 9. 9 was your remainder, right? So you can say R9 is how you first learned about that. But what was the remainder? Otherwise known as a fractional amount, right? Isn't that the same thing as 9/13?
Oh my gosh.
I guess they have a grader the other day.
Oh yeah? Good. It all comes back. So now, it's the same basic principle, but we're going to do polynomials.
Oh my God.
Now, here's the thing. Textbooks, worksheets, CUDA, most things always write out division horizontally, like this. They don't write it the way we just did with doing the long division where you have the 13 into that big giant ugly number. So when we go to do this, as you write these down, what I need you guys to do is write down x minus 2 on the outside, and then on the inside, well, it's a third degree polynomial, which means how many terms should it have? 4. What's it missing? X squared. So I'm going to put x cubed plus 0x squared minus 7x minus 6. Now, when you're long dividing with polynomials, it's actually a lot easier than with numbers. Really. Because what you're trying to do is, with each consecutive step that you take, you're trying to figure out how to eliminate a front term. Here's what I mean. If I want to get rid of an x cubed, what do I have to multiply x by? X squared, okay. So if I multiply x squared, take a guess where I would put the x squared in that sequence.
At the top, on like.
Above which one? X squared. Now here's the thing. How many terms are on the outside of the polynomial here right now? Those, correcto. So I should probably put it above the second one over here. What's x squared times x?
X to the third.
What's x squared times negative 2?
2x. Or negative 2x squared.
Okay. When you long divided earlier, what did you do in between each of these steps? What do you think you had to do here? Subtract. So now, here's where, oh, careful. Remember, these are, when you're subtracting polynomials, you're lining up in order of the degrees, and then you want to treat each one of them as their own subtraction problem. X cubed minus x cubed is 0. 0x squared minus a negative 2x squared is 2x squared. So remember, you've got a same change opposite there, and you've got a 2x squared. Now what do you think I need to do? Take a guess. Bring down the negative 7x. Good. So just like before, I want to now eliminate that 2x squared, which means I got to figure out what do I multiply x by to turn it into 2x squared? 2x. Good, 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 good. Is it positive or negative?
Positive.
Positive. I want to keep the same sign. So I multiply this by 2x. So 2x times x is 2x squared. Good. 2x times negative 2 is negative 4x. Good. Again, I have 2 subtraction problems here. First term goes away. So what's negative 7x plus 4x? 3x. And now I bring down the negative 6.
I'm actually multiply it by -3.
Very good.
With the -3.
Very good. Everybody see how you multiply that now by -3? Because I want to turn this value of x into the exact same thing here. Distribute through. And then -3 times -2 is what?
-6.
+6. And then subtract. So this one goes away. This one becomes -12. All right. That just means it's my remainder. Okay. What'd you do with the remainder here?
You wrote it as a fraction.
So what do I do here?
Write it as -12 over x. Is it 12 over x?
-12 over.
This is crazy. Okay, but like y.
What do you mean?
Y.
So eventually we get to what are called rational expressions. And rational expressions have graphs. And rational expressions have, it'll be, one second, sir. What we're going to do at the end of this semester is we're going to talk about something that looks like that. That's a hyperbola, okay? When we get to rational expressions, hyperbolas can go this way, which means they have what are called slant asymptotes. Oh wait, I'll get you 1 second, Sarah.
Would it be positive 3 and then be
This one was a -3, so I wanted to make it, I have to make it into the exact same.
then it would be a negative 6.
When I-
and we would subtract the
When they subtract the -3 minus a -3x, it eliminates through, and then
But if it was positive 3, so you times up.
what? This one 3 or the other one?
Never mind.
Okay.
Why would they put, like, why would they put the x cubed?
See how there's two terms there?
Yeah.
I want to, if I put this times this, it gets me to this same value here. Because there are two terms. I'm creating two terms. Okay, that's another little thing. There's little subtle things you'll pick up. All right, let's try another one. Okay? Same idea. Oh, I'm sorry. But yeah.
So what's your final answer?
That last thing with that, the whole top with that -12 over the x plus 3, whatever was that left hand fraction. Okay. I just explained that.
I know.
But you've done one, Trinity. Give me more than one example to walk through, okay? Okay. Same idea. I have a third-degree polynomial divided by a linear. So, excuse me. When you start this one, third-degree polynomial has to have how many terms in its sequence? Does it have all 4?
Yes.
Okay. So that's one of the first things you should ask yourself as you're going through. The outside is going to go 2x plus 3. On the inside will be 2x cubed minus 7x squared minus 17x minus 3. For those of you with less than desirable handwriting, space this out, left to right. And space this out. And then you ask yourself the question, what do you have to multiply 2x by to turn it into 2x cubed? If it was 2x squared, I would have gotten 4x cubed. So it's just be x squared again. Okay? Remember, you want to turn this term into this. So it's got to be an x squared. And once again, the reason why I'm putting it above x squared, see how I've got two pieces outside? When I multiply it out, I just want to have two pieces to subtract from. Okay? So distribute to here, you get 2x cubed. No, I'm multiplying this just by x squared. I'm not squaring the whole thing or cubing the whole thing. All right? So when I distribute that through, then I get plus the 3x squared. And then I subtract. The 2x cubed go away. And then you're left with a negative 10x squared. Okay. What do I multiply? Yeah, what do I multiply the 2x by to turn it into a negative 10x squared? Negative 5x, good. So multiply by negative 5x. Distribute to the term on the outside. We get negative 10x squared. And then negative 5 and positive 3, negative 15x. Okay? When you are subtracting polynomials, remember you're subtracting each piece. So always put two subtraction symbols here. Negative 10 minus a negative 10 goes away. Negative 17 plus 15 gives me negative 2x. And I bring down the negative 3. What do you multiply negative, or what do you multiply 2x by to turn it into a negative 2x?
Negative 1.
Negative 1. Okay.
And then all this
What's that, sir?
But then we're having positive.
Bless you. No, because I want it to be the exact same. Because when I subtract, what's negative 2 minus negative 2? 0. You always want to make notice each one of these terms as I'm bringing them down here, I'm multiplying this value by to turn it into the exact same thing. So when you subtract, it goes away. Did I have a remainder? No. Which means, what's that? No, what?
I don't know if I'm right.
What are you going to say? The top part, the x squared minus 5? Well, if you look at it, can you factor x squared minus 5x minus 1? What times what's negative 1 gets you negative 5? That's not factor. That's not fun. But what I do know is that since there's no remainder, didn't this get factored out of here?
Oh.
Remember this from yesterday? What's 34 divided by 2?
17.
17, okay. We knew that that was 17, right? How do you check? What's 2 times 17? So what happens here is that I know that 2x plus 3 times x squared minus 5x minus 1 will give me 2x cubed minus 7x squared minus 17x minus 3. And the reason why that worked, because what was my remainder? 0. Which meant that the 2x plus 3 is in fact what we would call a factor of it. But it's not Monday anymore, so there's that.
Oh, yeah.
Okay? You don't have to multiply it out. Let's see. All right. Well, let's throw something weird at you then. I have a 4th degree polynomial being divided by a 2nd degree polynomial, which means if I have a 4th degree polynomial, how many terms should it have? If I have a 2nd degree polynomial, how many terms should it have? So you need some placeholders here, it looks like, don't we? Okay. So I know on the outside I have an x squared plus a 3x plus a 0. On the inside I have 5x to the 4th, 14x cubed, 0x squared, 9x, and a 0. I have to have placeholders no matter what I do. Okay. So far, so good? All right. Yes, sir.
Why, last term, there's not an x?
You still, because any nth degree polynomial has n plus 1 terms, and for any of this to work, whether it's synthetic or this long division, those placeholders need to be there. Otherwise, things get messed up because you're missing a term. Okay. So, what do you multiply x squared by to turn it into 5x to the 4th? 5x squared, right? Gee, what am I going to put that over? the x squared. Now, another thing you'll notice is that by putting it over the x squared, there's 3 parts here because there are 3 parts here. See where that goes from? So what's 5x squared times x squared? You get 5x to the 4th. 5x squared times the 3x gives you 15x cubed. And then 5x squared plus times 0 is 0. I'm just going to write x squared as my placeholder. Okay? What do? You subtract each piece. 5x to the 4th minus 5x to the 4th is gone. 14x cubed minus 15x cubed gives you negative 1x cubed. So it's negative 1x cubed, 0x squared, and a 9x. Keeping my placeholders. What do you multiply x squared by to turn it into negative x cubed? What do you mean? Correct. Yep, keep it there. Placeholders have to stay. Yep, negative x. Bring that through. Negative 1x cubed. Negative 3x squared. And 0x. Remember, when you get to this point here, I can't stress this enough. Make sure you're writing these polynomial parts here, each one as its own subtraction problem, because you will forget. I know you're going to forget. By putting that little subtraction symbol in there 3 times, it will remind you to subtract how many times? 3 times. Excuse me. That goes away. I get 3x squared, 9x, and a 0. What do you multiply x squared by to turn it into 3x squared? 3. Bless you. Bless you. What's my remainder?
0.
You just factored out stuff. Aren't you excited? Now, notice, one of the things that happens is your degrees are dropping as you factor stuff out, aren't they? Okay, and that's okay. Now, one of the things you should also notice is that if you started to multiply these things back together, what's x squared times x squared going to get you? X to the 4th, okay? Your 2 highest degrees should always multiply out to be whatever was underneath that to begin with. Okay? That's long division. Now, like I said, long division comes into play a lot more in a little while. The idea, though, is that you're still breaking things down. Things are dropping degrees as you divide stuff through. It's kind of the same idea when we start using synthetic. When you use synthetic like this, if I want to take x cubed plus 2x squared minus 6x minus 9, and I want to divide this by x minus 2. And I want to do this synthetically. Synthetically was that stuff you guys did yesterday. When you did that yesterday, if you wound up with a number at the last spot, that was your remainder, wasn't it? If you wound up with a 0, that meant that it was, yes sir, please go right ahead. If you wound up with a 0 for remainder, that meant it was a factor. Kind of like that 34 divided by 2, that idea. Now, here's the idea. If I'm going to use synthetic here, we still follow the same rules as we did yesterday. We take our coefficients. 3rd degree has 4 terms. It's got them all. 1, 2, negative 6, and negative 9. If I am using synthetic, when they give me a term, you always use its 0 on the outside. So, correct. If x minus 2 is my term, my 0 is 2. If x plus 3 is my term, my 0 is negative 3. You always have to divide, when you're using synthetic, by whatever this value's 0 is. What's the first rule? Drop the 1 down. Multiply, add, multiply, add, multiply, and add. Is x minus 2 a factor of that?
Yes. No.
No, it's not, because I didn't end up with a 0. Okay? So, do that again. The other one was what? X plus 3? So I use negative 3. Bring this down. Multiply. Add. Multiply. Add. Multiply. Add. Did I get a 0?
Yeah.
That means that this is a 0 of that function. Okay. There you go. Now the idea here is, you notice how I got a 0 at the end there, and I just went back and circled the 0 that created it? That means that x minus 3 is a 0. What's the term that makes x minus 3? Or excuse me, it gives you negative 3. X plus 3. So the term would be x plus 3. Now, if I had to multiply something by x to turn it into an x cubed, what did that have to be? X squared. So that means that this I'm left with is x squared minus 1x minus 3.
Oh, right. I mean, so that's just the product of the multiple.
Yeah.
Oh, so how would you do something?
What do you mean? Well, do you agree that this was a 0?
Yeah.
If that's a 0, that meant there was no remainder if you long divided. Okay. So if that was if that was the 0, the term that generated that was x plus 3. So in the back of your head, what do you multiply x by to turn it into an x cubed? X squared. And then you have 3 terms, right? Coefficients.
Oh my God. So wait, what do we do?
You still got to learn how to do long division for polynomials later on. It depends on what you had to start with. Now, if you have long division, remember how we did the trinomial? You can't do synthetic trinomial, you can only do zeros of singular terms.
So we find out that there is a 0.
All right, let's try again. Oops, do this one. So I'm going to use synthetic. They're giving you the term they want you to try and divide by. And they're giving you that stuff up front. Excuse me. So the first one you're dividing into x cubed minus 8x plus 3 means it's a third degree polynomial, which means how many terms should it have? 4. What's it missing? X squared. So where does that 0 go? Between what two? 1, 0, negative 8, 3. If I'm dividing by the term x plus 3, what's my 0? Negative 3. What's the first thing you do? Multiply. Add.
Oh, it's a 0. Oh, it's a 0. Wow.
Was that a 0?
Yeah.
So if negative 3 is a 0, what was the term that generated the negative 3 again? X plus 3.
Oh, wow.
Then it wasn't a factor.
That's so great.
And now what are you left with in here?
X squared minus 3x plus 1. Oh my gosh, that's so great.
Okay. All right. X to the 4th minus 16x squared plus x plus 4. Fourth degree polynomial, how many terms should it have? Is it missing any?
Yeah.
It is. What do you put in place for 1? 0 for the x cubed, correct? Okay. Same idea. I have 1, 0, negative 16, 1, 4. X plus 4 is my term. What's my 0? -4, good. Bless you. First thing first, drop down the 1. Now what?
-4.
Multiply, -4, add, multiply, add, multiply. Oh, sorry, you're right. Add. It was a 0, which means its term was. And now what are you left with?
X cubed minus x squared or -4.
Plus 1. Good. They're applauding. It's great. No, Jack. Yes, sir. Go, Jack.
It's just like,
What's that? Yes. Yep. It drops a degree. Because remember, what's happening, guys, this is a great question. Once you get a 0, that means that this is dropped to 3 because you were able to factor out that term. When you factor out a term, the degree goes down 1 because what's x times x cubed? Gives you x to the 4th. Okay? Now, synthetic is going to be your best friend because you're going to be able to factor polynomials if you know a 0. If you know a 0, you're going to be able to factor a polynomial. For example, if I'm looking at 2x cubed minus 11x squared plus 18x plus 9, it's got 4 terms. You guys would probably sit there and think, oh, I can factor it via grouping. And then you would have ran into the problem that nothing worked out clean out of that. But if you know a 0, you know where to start. So if they say that -3 is the 0, is that the 0 or the term? 0. Okay, so if they're giving you that f of -3 is the 0, that means the -3 is on the outside. Third degree polynomial has how many terms in the sequence? It has 4, right? Does it have all 4? Yeah. Put your coefficients. Okay. What's the first thing you do? Drop down the 2. Now, according to this problem, it told you that this has to be a 0. So this has to work. Okay? So hopefully you don't unmath or math this badly. -3 times 2 is -6. Add 5. -15. Add -9.
Oh my God.
And a 0. So like we just said, we have a 0 at x plus 3. What does this become? 2x squared. What times what is 6? You add together to get 5. 2 and 3. Now you can factor it the rest of the way. Oh, it said factor the polynomial given a 0, which means you can factor it all the way out, which means you're going to get 3 terms because this is a third degree polynomial. Right? Cases should have 3 zeros. This isn't anything different than what we just did. Take out your GCF. So if this one comes along, you get x plus 3, x plus 1.
Wow. Bruh, that's crazy.
So it winds up being another way to factor something if you know where to start.
Now you gotta find all the words.
Not yet. We'll do that later. I don't know what we're doing for the quiz yet. I haven't figured it. I haven't decided if we're going to continue the quiz or just make this the test to save ourselves a day here, because there's so much more stuff to go through. Okay. So what we got then in, oops. Sorry, let me get this up here real quick.
Oh my God.
Let's do this. Let's find our zeros. We'll hold off on the long division for tonight. We'll do some more of that tomorrow. They're giving you the zero of one of them. You need to find the other zeros. Okay? I'll have the PDF up in a minute. We'll just do those 8. All right? You're given 1 0. Negative 14 is a 0. Of that, find the other 2 zeros using synthetic. So it'll drop itself through, and then you'll be able to get the factor stuff. All right? They're only third-degree polynomials, so they're not going to be that bad. Bless you. Okay? Yeah, I'll have this all posted up. I didn't know how far we were going to get through on stuff. Yep, that's 0. After the bell rings.